Well, it looks like we have another one. Maybe this one will do something exciting. Never know. Can't see too many examples. And sometimes it'll be like this weird thing, you just can't recognize it necessarily by looking at it. Okay. So here we go. Number 1. Well, this time I've got the 3x minus 2y is greater than or equal to 12. Let me write it down as an equation. And then I'm going to get it in slope-intercept form. We did one similar to this. So put the 3x on the other side, divide everything by -2. Now, the fact that you're dividing by a negative, it doesn't really do anything because this is an equation, and that's one of the reasons why we graph the equation. Then we go back and deal with the inequality part later. Okay, so I get 3/2 x minus 6. That's what it looks like to me. And so I have a slope of 3/2, and I have a y-intercept of 0, -6. Okay, so let's plot 0, -6. 1, 2, 3, 4, 5, 6. There we go. And then up 3 and over 2, up 3 and over 2. And it's going to be a solid line. And it draws many points this time. Now, let's just for once, let's pick a point that's not 0, 0, just so I can show you. I said that on the last one. So I'm going to pick a point, let's see. I don't want to pick it too big. 8, -2. So it's this random point, and I'm going to graph it for you. So 8, -2 is right there. And I'm just going to see if that point works in the inequality. So the process is the same. I usually pick 0, 0. But this time, I'm going to my inequality here. 3x minus 2y is greater than or equal to 12. And I put in an 8 for x and a -2 for y. Now you might be saying, well, why'd she pick 8, -2? I just picked a random point. I didn't want it to be close to the line because, as you can see, my line's not drawn very accurately. So don't get too close to the line. But a lot of times you can go with the origin, 0, 0. So I get 3 times 8 is 24, and -2 times -2 is a +4. Is that greater than or equal to 12? Yeah, it looks like it. 28 is greater than or equal to 12. So yes. What does it mean? It means the point that I picked works. So that's in the shaded area. Okay, so that was fun. Okay, and now we'll go to the second one. The second one, it's already in slope-intercept form. And you might notice something about this. The slope is the same as the other line. What does it mean? Let me finish writing this here. So the slope is 3/2. The y-intercept is 0, 1. 0, 1 right there. And the slope is the same. Well, what do lines that have the same slope, what does that mean? 1, 2, 3, 2. I still can go up 3. I can still graph it. It means those lines are going to be parallel, right? Okay, so solid or dotted? It's solid. And, yeah, my rulers aren't straight, but those are supposed to be parallel lines because they have the same slope. And if they don't look parallel to you, it's just because I can't draw. Okay, but those are parallel lines. We still keep doing the problem, though. So you can say, hey, these lines don't intersect. That's true. But we still are going to finish the problem. So I'm going to pick the origin this time. Why didn't I pick 8, -2? I'm just going back to old habits, picking the origin. So use the inequality. Y is greater than or equal to 3/2 x plus 1. Put in a 0 for y, a 0 for x. So I get 0 is greater than or equal to 1. 0 is greater than 1? No. Okay, so not where 0, 0 is, not where the origin is, not there. The other side, so over here. Okay, now we have to make some conclusions here. Normally, we graph both lines and they intersect, right? And we do the shading and we find where both the green and blue match. This time they're parallel lines, which is fine. They can be parallel lines. We did the shading. We did everything correctly. Where are both the green and the blue lines? Well, they don't overlap, and they're not going to. And so there is no solution here. So we were just going to write no solution. There aren't any points that will satisfy both inequalities. Sometimes that happens, but it's okay. We did it right.